Equations. We want to look at what equations are, first of all. Now, an equation is simply a statement that says one thing is equal to another, right? Or, a combination of things is equal to another combination of things. So an equation is simply something like this. A plus B is equal to C plus D. So this is equal to that. So it's just a mathematical statement that equates two groups of items. Now, we want to look at the basic rules when solving equations, right? The rules revolve around the equal sign, right? And movement across the equal sign. Now, what happens is that the equal sign separates the equations into two sides, right? Here you've got the left-hand side of the equation, and then you've got the right-hand side of the equation. When an item, right, a number, a letter, moves across the equal sign, it must perform a function opposite to that which it was performing on the side it was, right? So it must perform a function which is opposite to that which it was performing on the other side. So if we're going to solve this equation, we're generally looking for x, right? If we're solving, we're looking for the value of x. This statement is saying 3x minus 4 is equal to x plus 8. So our question is, what is this x? What number is this x? What number can you multiply by 3, subtract 4, and it will give you a result which is equal to adding 8 to that number. So that's all it is. When you're solving an equation, you're finding this unknown value represented by the letter. So how do we do it? We collect like terms on either side, right? So I collect all terms with x on the left-hand side and all terms without x on the right-hand side. So my 3x is already here. Bring my x this side. X was positive, right? Positive x. So if there's no sign here, it means it's a positive x, meaning it's adding. So when it comes this side, it becomes negative x, right? And then 8 hasn't moved. It's still on the same side, so 8 remains positive 8. And then 4 was a negative 4, so if it moves to the other side of the equation, it changes and becomes a positive 4. So 3x minus x gives us 2x, and then 8 plus 4 gives us 12. So now we have simplified this to this statement here, 2x is equal to 4. This is 2 times x is equal to 4. So to remove 2, we have to cancel 2 off by dividing by 2 on both sides. So 2 is cancelled off there. I just have an x, and then 12 divided by 2 gives you a 6. So that's it. 6 is the value of x that we were looking for. Here's another equation here. We perform the same actions, right? You collect terms with y on one side and terms without y on the other side. So in this case, let me take my minus 9 that side and take my minus 3 to the right hand side. So 7 doesn't move. I bring minus 9. I get plus 9 since it was a minus. Then 5y didn't move. I take this to the other side. I get plus 3y since it was a minus. It changed signs. 7 plus 9 gives you a 16. 5 plus 3 gives you an 8y. So 16 is equal to 8y. And then when I'm here, to remove this 8, I have to divide both sides by 8. 16 divided by 8 is 2. And on this side, the 8s cancel out. I have y. So I found my value of y, which is 2. Y is equal to 2. So here's our last example. Again, we must have like terms on one side and another set of like terms on the other side. So we've got a 0 there. I can take my minus 3 that side where it becomes a plus 3 and then leave my 2b and my 4b on one side. So I'll have 2b plus 4b, right? They remain the same because they didn't move across the equal sign. Minus 3 goes the other side, becomes a positive 3. Get a 0 plus 3. Although it's 0, in some cases you can just omit it and not even mention it and just have your positive 3. So 2b plus 6 plus 4b, sorry, gives you 6b. 0 plus 3 gives you 3. Now this is 6b. I want b, so I divide both sides by 6. So this cancels out. I'll have b is equal to 3 over 6. Divide by 3, both numerator and denominator. In lowest terms, b is equal to half. So those are the basics of solving equations.